So the title of my presentation is The Rise of the Machines and the Role of the Treasury Professional in the New World Order. So the idea was to be a little bit provocative, but I don't think the world is going to turn out as badly as maybe we fear. And there's a lot of, I apologize in advance, some of the slides are very focused towards Treasury people, but I'm going to try and make it, given the audience, try and maybe over-explain some things to people who are less familiar with what we do in Treasury. Or as kind of a compliance guy once said at a meeting, I didn't realize so many senior people were here, so I have to make things more simple, which did not make the executives particularly happy. Essentially, let me see if my clicker's not working. So maybe I'll do, what do we do? I think I may be missing a button. Okay, so just going through, essentially what I wanted to talk about was we're in a world now where people and computers are partnering. So essentially where, you used to think of, well, there's certain things that people do, there's certain things that computers do, but as we come into this more, what we almost call a man-computer symbiosis, we work together as partners with machines. And there's certain things that machines do particularly well, which is really processing data, moving things from one place to another. There's certain things that people do well, which is really about strategy, learning, essentially getting to a point where you've got people now can do the things that are more interesting, essentially, and leave a lot of the drudgery to computers. So I have a nice set of pictures here. We can go to, you can just flip through the slides if you want now. But anyway, the story here is basically what have we done in the last 100 years in technology. So we all kind of know that technology has really made our lives much better and machines much better. But just wanted to give some examples, from page 2. Next page. There we go. So I wanted to give some examples of what does it mean, in a couple different industries. So there's an interesting quote from Good Housekeeping magazine in 1930 that said, how many women wish there was a button that could just, basically make dinner for them and clean things up. And you forget that this is years before microwaves and dishwashers were invented. In terms of health, actually Chicago created one of the first city sewer systems about 100 years ago. Before then, there was sewage in the streets, there was very little indoor plumbing, and waterborne disease was the third largest cause of death. Cars, there was 141 miles of paved roads outside of cities. And you could buy a telephone, about 100 years ago, but you still had to buy one telephone and another telephone and the line between them because there was no telephone network yet. And on the next slide, you'll see that there's a lot of stuff that's been happening in the payments industry as well. So we're looking at, originally things started with barter, moving towards, coin and currency and check. So things are getting more abstract. And then you get to electronification. So the big kind of turning point in electronic payments is in 1871 when Western Union used their telegraph network to put the first wire transfer through. Then you end up in really looking forward to where we are today, and you've got online banking. So CitiDirect is our online banking platform. This is the corporate banking platform we use for our clients to log in, make payments, do what you think of as online banking. But more interestingly, to some extent, is what's happened after that, which is essentially machine-to-machine transactions. And I'm going to talk a little bit about that today, why do you even need a person involved to make some transactions if you already know what they're going to do? So moving on to the next slide, We have, what is TTS? What do I do? And you can think of what we do you may not have heard of our bank, but for Citi's treasury management system, we are the largest corporate global bank. So we're in 100 countries, and one way of thinking about it is pick your largest beverage company or your largest telecom company. They've got to make payments to people in 100 different markets. They need banks in 100 different markets. And that's really where we come in. We're their bank. We can help them make payments in all these different places and really provide a cohesive structure over 100 different regulatory systems and really make it transparent to them. So just getting into, on the next slide, there's two ways of making payments, essentially with people or without people. So starting with the without people, you essentially have a bunch of different ways. Either you can use files, you can use ERP systems, but the goal is how do you make a seamless connectivity between somebody's business and the bank and not have people intermediating this. So if you go to the next slide, what we have as our sort of core system here is called Citi Connect. Now, if you think about a business talking to a bank, normally you've got a person in there as a payments clerk, kind of just making payments to various different people, right? So a person, inputs whatever payments need to go in accounts payable, and all these transactions go through. But there's easier ways of doing it, or more efficient ways of doing it. Essentially, in a lot of big companies, you spent all this money implementing SAP. So what does SAP do? It manages all the resources. It's enterprise resource planning. So it manages all the resources of a company. So it knows all the things coming in, all the things going out. So for instance, if you're setting up a new factory, it knows you need to buy desks, it knows you need to hire new people. If it knows all these things already, it knows what the accounts payable are, why do you need a person to key that into the bank? And what Citi Connect does, it takes all of the payment instructions that are already in SAP, removes the payments clerk, and sends it directly to the bank. And this is a much more efficient way of doing things. And for all the stuff we're talking about, in consumer banking, how do we get mobile payments? How do we get these other things? This is really how do payments just magically happen? Of course, it makes more sense for banks, for companies, because companies have a lot more invested. There's a lot more money. There's a lot more people in it. But this is the types of things that we're going to start seeing more and more of in the consumer payment space. When you go to the next slide, you'll see that there's what we have on the top is, sorry for the small font, but it takes a lot of effort for someone to reconcile a set of payments. So basically, a payment comes in, you send out 1,000 payments, 3 of them are rejected, somebody looks at a report, they look at what went out, they look at what came back, they tie the numbers back, they figure out what the exceptions are. It's a very manual process. It shouldn't have to happen that way. And what we end up with in our Citi Connect system is, essentially we're saying, how can we make this better? We can make it better by giving more data to the clients and really reconciling these things together to somebody before it comes in. So you essentially have enough data and enough, in addition to just sending data out and getting data back, we can also get to the point now of what we called before straight-through processing. We're now doing straight-through reconciliation. So removing people from that situation of having to look into and match all these different payments and understand what's happening, and just basically get an exception report and say, here's the 3 payments that didn't go through, here's some ideas why we thought they didn't go through, and just make people's lives much easier and get a lot of the drudgery out of this. So we go to the next slide, we get to the actually interesting part of what we're talking about. Because for us, this is just moving data back and forth. It's interesting, but it kind of makes you think like, what are people going to do in this world? We have great solutions for mobile and online and tablet, for the corporate bankers, but it's not. If everything's moving to machines, why do we need people? Why, are there going to be any treasury professionals, or is everything going to move to a file-based system and just ERP systems connecting to banks? And I think what becomes really interesting here, if you go to the next slide, I'm going to tell a story about chess, which is obviously what people do at a payments summit. So if you remember, in 1997, there was a big chess match, right? This was the biggest human-computer chess match that had ever happened and probably will ever happen, right? Where Garry Kasparov, played chess against Deep Blue. The first match with Deep Blue, Garry Kasparov really pulled it out at the last minute, but then Deep Blue had the advantage of going back, getting more hardware, coming back, and then beating Kasparov in the rematch. And if you think about it, like, this should be the end of human-computer chess, right? So the question I have up there is, of course, right, this is the end of human-computer chess. Except if you go to the next build, it's not. What Kasparov did, which is very interesting, and he said, what if we, and on the source on the bottom, it's quite an interesting little book review he wrote talking about artificial intelligence and the future, and it's quite surprising to have a guy who everybody knows is a chess guy is almost a philosopher on artificial intelligence and innovation. But he said, okay, Deep Blue beat me as Garry Kasparov, but what if I had a computer for myself? And not like a supercomputer, but what if I just had a laptop, that could do a lot of this kind of heavy lifting? So Kasparov at a computer could beat Deep Blue really quite easily. And it also changes the dynamics of the way other grandmasters play. But essentially what happens is Kasparov does the strategy, and his laptop can go and make sure he doesn't make any silly mistakes and really go deep into strategy and understand what's going on. So what you end up with is, Kasparov and a computer are better than any supercomputer in the world. But what's interesting is that that's not the most powerful thing. So in 2005, this online website called playchess.com gave a whole lot of money to say, okay, whoever wants to play chess, play chess. You can have a computer, you can have a person, you can have a computer and a person. You can do whatever you want. You can have 3 people. Anything that's normally defined in online chess as cheating was valid for this game. And Kasparov's playing, a bunch of other people are playing. And you'd think, and for a while people did think that there was a team that was winning all the time. And they thought this was Kasparov and his laptop, and that's obvious what was happening. But what's interesting is that in the next build you'll see that wasn't who won. So if you go to the next little bit, the winners actually was 2 okay players and 3 who had 3 computers. And they weren't good computers and they weren't good players, but they had built a system which basically was these 5 things, 2 people and 3 computers, were able to build a system that was far better than anybody else. Beating Kasparov, beating Hydra, who's the grandson of Deep Blue. And it was fascinating, and this was a truly odd experience for everyone playing in the match. How could these 2 guys who were totally not as good as any of the grandmasters playing, win this match? But the key to it is that they did it by building the best system. So this was essentially the fact that it wasn't about the players, it wasn't about the computers, but it was about how everybody worked together. And this is a pretty standard, this is an old concept from computer science, and it was first expressed by this guy, J.C.R. Licklider, in 1960, and called man-computer symbiosis. And Licklider is actually the guy who created the internet, not Al Gore. It was literally Licklider's lab at DARPA said, let's fund interesting experiments, let's go build this thing called the internet. And he's done it's a fascinating kind of time in computer history. So on the next slide, we kind of break down into, let's think about how this really works. So we've got humans, we've got computers, we've got humans and computers working together. So when we start thinking about humans, what are humans good at? Humans are really good at selling things. Computers aren't particularly good at sending you email and trying to convince you to do anything other than, answer spam. And they're not even that good at that. They're good at managing audits. So if there's human processes involved, you do need people involved in these things. Dealing with crises, right? So there was somebody brought up an interesting example of, if there's an earthquake in some country, and you're trying to build up, trying to help people and get people back on their feet. Computers don't know how to deal with these complicated situations out of nowhere. And you wouldn't want to program a computer to do that anyway, because trying to program all the edge cases just isn't worth it. There's things people are very, very good at that computers just aren't. As we talked about before, computers are really good at processing a lot of data, moving a lot of data, kind of just getting things from one place to another and transforming them. But what do people and computers do together really well? And this is really about, so strategy. People are really good at setting a strategy. Computers are really good at tracking that strategy. Judgment. People at the end of the day have to be personally accountable for what's happening. And computers are good at setting those controls and making sure that those people are accountable. In terms of improvements, people are good at analyzing the trends and making the systems better, and computers can provide that data that does it. And then finally, like we were talking about before, from a cost perspective, there are certain things that just eventually you could do with a computer, but because the market is too small or because the technology is too expensive, it's just much easier to get a regular person to just do it as opposed to building a big system that does everything. So on the next slide, I've got a nice example of this in kind of the automotive world. So most people think they're driving their cars today, right? But what we saw with the GM recall is people aren't driving their cars as much as they thought, right? Because what you'd think would be, hey, you're driving a car down the street, your car turns off because the ignition switch turns off, so, your radio doesn't work, right? But that's not what happened with the GM cars, right? Your steering didn't work, and your brakes didn't work, and your airbags didn't work, right? You are in partnership with your car, to get somewhere now, which is an odd concept, but it's much more true than I think we think about most of the time. But what you think about, humans still they do a lot. And the Google automated car example becomes quite interesting here. Because if you think about it, Google could drive your car, right? And especially you see, fancy cars like Mercedes is having having capabilities of making sure you stay in your lane, making sure that you brake correctly. But these are still, generally, these are still fairly expensive. And a self-driving car like Google's creating is much more expensive. So still, people, even for cost purposes, for a long time will be driving their cars. From a strategy perspective, people still need to decide where they're going. So there's you can even get in the car, you can navigate there, right? You would have said 10 years ago, people need to know how to read a map to get somewhere, which isn't really true anymore with navigation, but you still have to put where do you want to go. And then from a judgment perspective, people still need to be responsible for the car, right? So from a legal perspective, and this gets very interesting in terms of what we've seen recently, that people still need to be the one who doesn't get in an accident, right? Cars can do most of the driving, but can't do all of the driving because there's got to be somebody who basically takes that end accountability for driving the car. And then finally, you've got people who are looking to improve all this, and people can be building these systems. It's not like the computers will learn themselves yet. I hope that doesn't happen for a while, that computers kind of redesign themselves and build better systems. So we wanted to bring up some examples, in what we're actually doing from in CitiDirect, so in our online banking system. So the first thing is, there's a lot of places where it's useful to have people there, and people doing, cash processing, people uploading files. And when we think about, these people are generally just more flexible than computers. If you think about it, teaching a person is much easier than programming a computer. Computers scale much better, but people are much cheaper at getting up to speed. But when you do this is the classic sense of building a good user interface. So this is the sense of, you've got people doing this work. How do we make their lives easier? So we've stuck to the principle here of keeping simple things simple, right? So which is kind of odd, right? So if a person wants to do a simple task, they shouldn't have to go through a whole bunch of hoops in order to get there. And what we've done is we have a home screen. We have a lot of different functionality in CitiDirect, but we now have a home screen that lets people get to the key items that they want to get to, whether it's their transactions, whether it's inquiries, whether it's reports, and just have a series of bookmarks at that home page so they can get where they want to get quickly. As well as we've developed something called Quick Task, which basically says, let's redesign all of the simple tasks that people want to do, whether it's transactions, whether it's reports, whether it's releasing files or authorizing them, and putting them all in one place so that they can perform these tasks kind of at the click of a mouse, as opposed to going through a report and really trying to get there. So simplicity and cost, I think, is a key thing. On the next slide, we're really looking at building out analytics from a Citi Direct perspective. So we want to make sure that people have these goals about cash management. Essentially, your goal in cash management is how do you keep the right amount of money in the right countries? And this is a very human activity, right? It has to figure out what your tax laws are. It has to figure out what are the types of things that you really want to achieve from in terms of what your needs are. So you need to have market data understanding what's happening. You need to have an understanding of the regulations of what are the different laws in different countries. You need to understand your business strategy. So there's all these things that a person needs to do, but we have the analytical capabilities in terms of, first of all, giving you news data that's relevant to you, providing our expertise in terms of regulatory understanding, as well as giving you the deep analytics and understanding that you need inside the system in order to get to understand what your position is and the effects of what your strategy is. And we have this now on our tablet infrastructure, as well as a lot of stuff on the web. And in terms of different systems that we're looking at, mobile's not quite there yet because we don't see people really doing a lot of analytics on mobile. We see them doing other things that we'll get to. But it becomes very interesting that, there's with these different form factors, there's very different payments that people would like to do. On the next slide, this is what people really use mobile for. And this is the idea that was brought up before, that a CFO on a golf course, wants to be able to authorize a payment. What's interesting about it is that we can sell it as we're trying to authorize a payment in that it's convenient for people, and it is, and it's nice that they don't have to be at their desk. But you go one step further, which is, will the CFO be at their desk just to authorize a payment, or is the CFO going to be at a meeting? They're not going to. Maybe they don't go golfing, but they can certainly. They'll be at a meeting. They'll be out, meeting clients. And the point is, what normally happens is the CFO will say, "Okay, I don't need to authorize this. I'll delegate authority to somebody else." What's nice about being able to authorize a payment on a mobile device is that you don't have to delegate that authority. You can still hold all you can still have the control with the CFO or the senior person, and authorize the payment, but do it in a way that's easier and simpler for them and doesn't tie them to a desk, which is, I think the real control advantage here. And essentially what we have here in terms of controls is, this goes back to, I have the old safe deposit box model, right? That in corporate banking, you have a maker-checker model. You have a person who inputs a payment and then a person who authorizes it. And what becomes very interesting here is, this is a great human check, right? So if you have a person, so go back to the safety deposit box, right? In a safety deposit box, you have the person with the key, because it's their box, and you have a bank employee who has a key, who does some checks to make sure that you're not stealing money out of the safety deposit box. So similarly, in transaction banking, we have the person who creates the payment and then the person who authorizes it. This provides literally two different people colluding to have fraud, or even two different people who have miraculously downloaded the same malware. Basically, two different people on two different computers who have exactly the same kind of circumstances, if they're not really working together in a crime ring, really provides so much more safety and control than anything else really in a bank. And this is really the core of what we do. And then finally, we go beyond that to say, look, there's certain payments that you don't need that kind of level of security for, because say you're just moving money from one account in the bank to another account in the bank. That's not something where you need a whole set of approvals. But on the other hand, if you're making a $1 million tax payment, you want certain people to do it. You want a lot higher levels of security, and not security, but a whole lot more levels of control and people really looking at the payment than you would have if you were just doing a simple payment to a vendor, to buy which you would do on an everyday basis. So that customizable level of, so basically having control in the right place, having more than one person looking at a payment for almost all your payments, and then having different levels of customization in terms of the levels of control you want to implement are very important. And this is a core place where humans really do need to be involved in the payments process. And then finally, on the last page is really about improvements. So what we're looking at here is, we provide, if you look at what happens with your straight-through processing or your straight-through reconciliation, you've got lots of payments going through, but you really want to understand, how do we make the system better? How do I understand, what am I missing? And what we have here is a set of scorecards which say, for the payments that you have going out, or the receivables that you have coming in, how are they working? How can we analyze them? How can we make these things better? How can we just improve? How can we make the computers better to be doing more work so that we don't have people handling as many exceptions? So, so then on the last slide, just to sum up, what I have on the final slide next is a picture of my son. And his understanding of technology isn't so good because he thinks a mouse is a telephone. So human-computer interfaces don't always work as well as you want them to. Just thinking about, it's important, I think, to go back and think about, do we have people doing the right sorts of things and computers doing the right sorts of things in our businesses, right? So from the perspective of, any time that we're just moving data, or any time there's a task which is truly automatable, right? We should automate it, right? It's very rare that we should just have a person doing the same sorts of things, unless there's so many exceptions that a human would be cheaper. I think the other point is to look at controls and say, are there places where we should be having more human controls and more human interaction because there's more decisions that need to be made. I think it's very easy to go down this road and say, let's automate everything, but we end up in a position then which exposes us to a lot of fraud and a lot of risk, which only humans can really detect. And then finally, I think it's important to be thinking about this from how technology is changing perspective. Because what ends up happening is, if we look at technology just from the perspective of, what can we do today, certain things are much more expensive, certain things may be used by more humans, or certain things maybe we want more with computers. But as we end up with new solutions and interesting solutions, it changes the dynamic very quickly. So a lot of the assumptions we have around cost and efficiency with new products really do change. So that's what I've got, and based on the audience's previous questions, I hope people have questions or I've done something horribly wrong. Sure. Sure, very nice.
When you were talking about Citibank and the machines actually reconciling, sorry, my speaker is on. Or that's,
she's mine.
Being able to reconcile our payments, or e-commerce payments as well. Mm-hmm. Can they connect with the back office and reconcile to the revenue that's coming in? Is that?
Yeah, that's the point. It's a matter of, you've got a bunch of payments coming out, you've got a bunch of payments coming in. At least from our perspective, we want to have as much through that chain as possible. And the way we do it is by providing more detailed data than is standard. So there's a new format that's in the last 10 years, this ISO XML standard. Yes. And it allows just an enormous amount of payments data to travel through, not just here's the beneficiary, here's the amount, right? More than that, so that basically you can have that same payment structure go through the whole chain, through reconcilement, through payments, and that makes it so much easier because that's all the data that anybody has. It's just that they always used to be transformed and augmented and moved at different places. So we're seeing an enormous amount of stuff that you can do with more data than you were ever able to do before.
What is the timeline of that, or is that available right now?
It's available now in a lot of places. We're rolling it out. I mean, at Citi, we've got 100 countries, so it's all a matter of what do we roll out where. But there's a significant amount of it that's available today, and we've got some very large clients who are using it globally.
Okay, thank you.
So kind of a follow-up on that. I'm assuming, though, you have it structured, though, so it's just one-to-one matches. Mm-hmm. So bank to book, basically. But if you get into card payments or the ACH world and so forth, where you have a one-to-many potential and so forth, you wouldn't be able to do that type of reconciliation, correct?
Probably, but where would you have a one-to-many payments?
So you're let's say you're a real estate company and you've got a tenant who's got 20 properties.
Right.
So they're paying one payment for 20 properties. You're getting the data through the
Right.
system that should match, but now you've got many transactions on their GL system or a subledger system
Right.
that it has to match to.
No, but I think that's the point, though. As we have more data, right, these things have to match at some level, right? Like from a human perspective.
Right. No, I guess my point is the logic to do those more complex one-to-many, many-to-many type matches is different than just doing a one-to-one match.
Yeah, no, it is. But I think that's what becomes very interesting in this. So you end up with like when you've got enormous number of payments going in or out, right? And I guess the point is, we can do the really simple stuff now, certainly. We can do this, we're actually able to do stuff that's more and more complicated, right? We can never truly do a many-to-one match, but the point is, how do we split that many up into multiple ones that we can match against something else? And that's the trick, and it's not, and where we can do it, and how we do it becomes a matter of looking at the specific items and really, and really looking at it at a case-by-case basis. But we can do most of them now. Anything else? Very good. So we'll get to lunch earlier.
All right, so if no more questions, thank you, Robert. Great.